Bonjour y'all, Adrian Lombard here. Today I'm recording this video from my hometown in eastern France. I'm staying here until the end of May, which means that the next chapter of my procedural masterclass won't be available before probably mid-June. In the meanwhile, I'm aiming to release some of my old Patreon content. A lot of you wondered what happened to my Patreon. Well, I had simply to put it on hold just because I couldn't keep up with creating content, taking care of my main job, and so on. So for my mental health, it's just easier to take care of Gumroad and YouTube whenever I have free time. Now, the videos I created for Patreon, some of them are available into my Gumroad, like the Mystic Towers. Those extra bonus videos are part of the project files. But some other videos are just never been released, and that's the case of the video of today. So I will be sharing with you some shading tricks using Redshift that I applied on my Neo-Gothic architecture. That's a project that I started like 3-4 years ago. Take it with a grain of salt. It's possible that some things in Redshift change. I don't know. I haven't kept up with it. I've been sort of busy focusing on learning Karma and Unreal Engine. Could be like, yeah, some things may have changed. Redshift was a great engine and was running fine even with my shitty old laptop. So just for that, I think it's a great engine to use. Without further ado, let's have a look at some shading tricks using Redshift.
So today we're going to talk about architectural shading. One thing to know is that a lot of it can be linked to the geometry by assigning attributes. So as you can see, I got some bricks of different colors, and this is part of my procedural setup within Houdini. It's time to check out the materials. So I'm going to break down how I did this shader. Still a work in progress, of course. There are a lot of details and stuff that are missing. So far, it's just a way to visualize what the final result could look like. Okay, so the first thing is we spend some time creating an attribute, and one way to actually import it inside Redshift is to use a scalar user data. And that would allow you to import any float attribute. So by default, it's UV tangent, so I'm switching that to brick and assigning a default value so that if you don't have any attribute on any object, it would automatically apply a value of 1. Otherwise, it would turn dark in this setup. And I got a fit range to basically contrast more or less this attribute, because remember, we have some values going from 0 to 1, so black to white. So in real life, the Hungarian parliament is not that contrasty, of course. That's why I'm refitting those values so that it doesn't appear that dark, and got some more subtle breakup, I guess. So 0.5 is still a bit too strong in my opinion, but at least you see what's going on, right? And how to control that? Well, this is plugged into the diffuse channel, and the diffuse is controlled by a color constant for the overall color. So if let's say I want to switch that to blue or red for some reason, I got this option. So this is the base color that I have. Actually, I'm gonna enable the denoise so that the render looks a bit better for this tutorial. Also probably gonna change the transform view to some Reg 709. I like this one a bit better than a sRGB. And yeah, from there should be good to go. So this is very bright, right? And the first thing I'm doing is creating some occlusion. So that's what's happening there. And we'll see how we can use that to actually apply some leaking. So let's create this ambient occlusion and plug that into the diffuse for now. So just by plugging that, we already get some pretty interesting result in terms of shadows and how everything is blending together. Now it's a pretty expensive node in terms of rendering time, so don't be surprised if things get significantly slower. And well, main parameter would be spread, so pretty self-explanatory. A lower value would result in more contrast. I'm gonna increase the max distance. Not sure if leaving it by default at 0 is a good idea, mostly because it can sample a bit too far, so it's a bit more optimized, I guess, to actually use a max distance. So we're gonna use the bias mode from there, and it's actually super useful because it's gonna help us to control the direction of the shadow. So the more we increase the y-axis, like as you can see, the shadow is gonna spread toward the bottom, like if the wind was blowing from the top or something like that. So we're gonna use a color constant to actually control this bias. So let's see, we're gonna plug that into the bias, and we're gonna replicate these values here. So let's set that to 0, 3, and 0. And actually we should get the exact same result. So you can actually control the bias with any map. Of course, we are interested in controlling that procedurally, so we'll use some noise to actually drive the bias. So let's create a max on noise. Okay. So I'm just gonna plug it temporarily to the diffuse to see what it's looking, and we're gonna switch the type to some fractal like FBM. And we're gonna contrast it by increasing the low clip and reducing high clip. So that should help quite a bit. We're actually gonna increase the scale Y to 2 just to give some more direction into this noise. And we're gonna reduce the overall scale to get more repetition. So that should help, I think. And probably a bit too much here. So yeah, maybe something like that. So we're gonna multiply this noise by the color constant that we just created. So pretty basic math. By multiplying, the black will basically cancel the bias, while the white will conserve the value that we are assigning in input 2. So in that case, it's a value of 3 in Y. So we got this green in terms of color, but well, we are plugging that into the bias, not into the color. And yeah, from there we have an occlusion that is controlled with this color constant and the max on noise. Yeah. So this max on noise, we're gonna call it mask, and that would be the global values, like values leaking. I don't know. So let's increase the max distance just in case, and we could try also to increase the value of the leaking just to see how it's spreading. I'm gonna store this render, and let's increase this value. So I'm gonna try 5. So let's store that and compare. Okay, so you see what's going on, right? Compared to what we had before, it's definitely helping. Okay, so one more thing that we could do, I'm actually gonna change that and try to contrast it more, and probably reduce the scale even more. So the more we contrast the mask, the more difference you're gonna have between the minimum value of the leaking. So that's why we got some larger flat area compared to before, where we had sometimes some small leaking. So it really depends what you are trying to achieve. It's probably more interesting before, in my opinion. Also, you can assign a minimum value. So 0.5, well, in that case, probably increase too much because there's not much contrast anymore. I'm gonna try, let's say 0.1. Yeah. So sometimes it's actually worth trying to have a low value instead of 0. Yeah, get the idea. So one more thing that could be interesting to experiment is to invert this value. And assigning a negative value, in that case, would change the direction. So instead of going down, it's going up. So that can be interesting. I mean, I'm not sure I'm gonna use that so much, but that can help in some situation where I don't know if you wanna generate some pollution or stuff like that. And you can also, well, combine both actually. So we have one part of the setup that's drive, the one going toward the top and one going toward the ground. So we could actually mix that with RS mult vector. And yeah, let's plug that to the diffuse, and now you are basically combining both. So I'm not sure this is the right settings. I would need to play more to get some interesting stuff, but yeah, I can try to play with the colors and the color value, and yeah, it's pretty bad. it's pretty contrasty in my opinion, but you actually can get a lot of cool result if you spend time to experiment. And yeah, I actually liked it before when we have less contrast inside the noise, and we could probably increase the spread to diffuse a bit more. Actually gonna decrease that to -3. Yeah, well, you get the idea. So comparing the different result, and yeah, well, why not? All right, so at this point, this is just another mask that we should use for diffuse. So let's grab those and make a network that we'll call leaking. And we want to combine that with the constant that we'll plug in diffuse. So I'm going to color correct that just to get a darker color based on this constant. So I'm going to plug it just to check out how it's looking. Just for sake of demonstration, I'll pick a very saturated color so we see what's going on. And with the color correct, I'm going to decrease the level scale to make it darker. Could probably play with the saturation. And basically, let's say we want to use this color to fit inside the black area of our leaking mask. So we're going to use a color mix. So I'll plug the original constant and the color correction, and in mix amount, we'll plug the mask. Let's try that. And maybe we could contrast a bit more those values. So I'm going to reduce the level scale even more. And actually, I realize I probably should swap those inputs. So the color correction should go in first one and the original constant in the second. And now we got this dark kind of brown color that is affected by the leaking mask. I'm going to reduce the saturation now and get something closer to the actual color of the Budapest government building. Okay, so from there we also want to drive some color variation based on the attribute we created earlier, which was brick attribute. So that was the attribute we have, and we will just actually copy this mixer and we'll plug the same kind of setup. So in mix amount, we're going to use the mask, the attribute that we created. So it's pretty extreme, but you see that we have brown now based on different connected piece. I'm going to switch that to 0 and 0.5, and yeah, it's a bit more subtle, I guess. Alternatively, you could also use another constant or any other noise inside the second input. And this way, well, I'm doing some kind of green that could be a base to get a moss, but just on specific bricks. I don't know. In that case, I'm just gonna apply some brown kind of variation, and can of course apply some different noise and stuff just on this specific section. So that's up to you. Of course, those settings were pretty extreme. In real life, this building is pretty clean, I guess. So I had to be more subtle on the leaking and the values of my attribute, my brick attribute. So you see that it's just some little shade of gray here and there, but it will need some more work, of course, like lichen, pigeon crab, scratches, who knows. And yeah, I'll do some more tutorials about it. Probably not the whole thing because it would take me forever to redo it, but just like this one, I'll do some little tutorial based on this project for sure. So stay safe, and I'll see you guys next time. So as you can see, I got some bricks of different colors, and this is part of my procedural setup within Houdini. So I'm going to show you how I actually get this effect of randomized color. So I created a little tool that's called ID generator. It's very easy. I'm going to demonstrate it with this piece. So just some triangles that sit on top of the building. And we have this tool assigning random color. So we'll create a seed control to randomize that. So let's dive inside this network. So most important is that we're going to use a for each connected piece. Loop. So to do this loop, we're going to use this one connected piece, and this will allow us to, well, as it say, loop inside every connected component. So we're going to use some basic vex to randomize the color, and we'll call an iteration attribute from the metadata of this loop. So let's create an attribute wrangle, and in the second input, let's connect the metadata. So in there we have the iteration that we're gonna grab using this line of code. So we'll set up an integer variable called iteration. So we want to call the detail attribute using the detail function. We need first to specify the input, which is the second input. And second input correspond to 1, the first being 0, actually. And then the attribute to call is iteration. And the index is 0 because it's a float. So from there, we're going to randomize that. So I actually did a typo. It's int to declare that as an integer. And let's create an attribute color that's going to be equal to a random function of the iteration variable. So if we try that, it's assigning random colors to each piece. And from there, if we try to multiply the iteration, it's going to return a different result, which would be the seed. So let's create a control for that, ch seed. And let's click on the plus to create the slider automatically. Oh, that's great. Now we have this control. Just make sure that it's a value above 0. And from there, we're going to remap this. We're going to extract, let's say, the red color. So at cd equal cd.air, and we are just isolating the red channel. If we want to say the blue, let's just do at cd.blue. And yeah, from there, if we want to remap, let's create a control ramp, and we're going to call that remap. So it's just a label, and we're going to remap this attribute. So let's create the control. So we do have the remap control ramp, and it's affecting the color of our objects. So that's great. And yeah, that's pretty much it actually for this tool. It's as simple as that. We could now store those values into another attribute. We're gonna call ID or brick. In my case, I called it brick to make it very specific. And well, we could just say at brick equal at cd.r. And as you can see, we got a brick attribute that's stored. We also got a bunch of random stuff that have been generated over the different procedural operations. So I usually like to clean that using clean node, and I remove every attribute except the most important one. Let's say brick, UV, normal. You want to keep this kind of attributes. Okay, could remove the groups. I don't need them anymore. And also the remove degenerate primitive. Let's disable that, otherwise getting rid of some important stuff. Actually, I want to keep the color as well, so let's write that. And we are keeping the color just for visualization purpose. All good. So from there, the tool is done, and yeah. Yeah, we are ready to shade. So I'm gonna display that. So I assigned this kind of same ID control to every element. So I actually modeled every brick procedurally. That's the one thing we could see later on.